Hello, good morning. Hello, good morning.
Good morning, sir.
Okay, can you see my screen? Okay, okay. So let's just wait for 1 minute for others to join. Okay, so let's get started. So we were doing functions, right? Okay, so let's start with a very simple function today. X minus 2 by x plus 3 is greater than 1. Find x. What is the value of x? Anyone, quickly. How do you find x here? Anyone? How to find x? Very simple equation, a very simple inequality, right? X minus 2 by x plus 3 is greater than 1. How do you find x? What is the value that you are getting? What is the value you are getting? Hello? Can you hear me?
Yes, sir.
Are you able to get any value from here?
No, sir.
No. Anyone? What are you getting? You're multiplying both sides by x plus 3, right? So you are getting x minus 2 is greater than x plus 3. That means you are getting minus 2 is greater than 3, which is not possible. So does it mean that it has no solution? Does it mean that this inequality has no solution? Yes or no? No solution? How many of you say no solution? Hello? Can you guys hear me? I'm not getting any response. Are you able to hear me, everyone?
Yes, sir.
Okay, please answer because otherwise I don't know whether you're able to follow. So how many of you are saying that there is no solution for this? Everyone says no solution? Is that the case?
Sir, if x is a big negative number, it will satisfy.
Tell me the solution. Tell me the solution. You have to give me a solution, right? So you are saying there is a solution, right?
Yes, sir.
You're saying there is a solution. What is the solution? You're right. There is a solution. There is a solution. So to solve this kind of an inequality, this, if you do this, then you're making a mistake. So what you have to do is, you have to do it like this: x minus 2 by x plus 3 minus 1 is greater than 0. And then you do x minus 2 minus x minus 3 by x plus 3 is greater than 0, which means minus 5 by x plus 3 is greater than 0. Now, if I have a ratio or a rational number a by b greater than 0, this means either a is greater than 0 and b is greater than 0, or a is less than 0 and b is less than 0. So these are the two possible cases. Here the numerator is negative, so the denominator has to be negative so that the ratio is greater than 0. So that means x plus 3 has to be less than 0, or x has to be less than minus 3. Now you put any value of x which is less than minus 3, you'll get the solution. You'll see that this is this inequality is valid. Right? Understood?
Yes, sir.
Yes.
So whenever you get a question on an inequality, if you multiply both sides by the denominator, you are getting a wrong answer. You always you have to bring everything to one side and you have to have 0 on the other side, whatever is the case. If you don't do that, then you are bound to get a wrong answer. Clear? Always. Right? So always you have to get it in the form of a by b, which will be either greater than 0 or less than 0. And based on that, your solutions will come out. So if it is greater than 0, then either both have to be positive or both have to be negative. If a by b is less than 0, then one has to be positive, the other has to be negative. This is how you solve inequalities like this. Okay. Next one. Y is equal to root over of x minus root over of 1 minus x square. Okay. And find x. What will be x? So how to solve this? This I told you in the last class when I was doing domain. So whenever you have a radical sign, whatever is inside the radical sign has to be greater than equal to 0. So I have one here and another here. So both these quantities have to be greater than equal to 0. So that means I have 1 minus x square greater than 0, greater than equal to 0, and x minus root over of 1 minus x square greater than equal to 0. Now both have to be satisfied. Okay, I have to satisfy both the inequalities. So from the first inequality, I have x square is less than equal to 1. From the second one, I have x greater than equal to root over of 1 minus x square. That means x square is greater than equal to 1 minus x square. So from here, I get 2x square is greater than equal to 1. So from here, what is the solution? If x square is less than equal to 1, what is the solution?
Between -1 and +1.
between -1 and +1. This lies between -1 and +1. So this is the solution from this. And you have to have another set of solution. So what is the solution from here? What is the solution from here?
X less than equal to minus 1 by root 2 or greater than equal to 1 by root 2.
Right. So x greater than equal to 1 by root 2 or x less than equal to -1 by root 2. So this is your second solution, right? So now you have a and in between. So it has to be both. So what would be my final solution? What should be my final solution?
So -1 to -1 by root 2 and 1 by root 2 to 1.
What is the value of -1 by root 2? This is minus root 2 by 2, which is minus 0.7, right? Roughly minus 0.7, right? So that means it should be less than minus 0.7, greater than equal to -1, okay? Or it can be greater than equal to plus root 7 and less than equal to 1, right? So that means that the combined solution from these two will be x will lie between -1 and -1 by root 2, right? And along with that, you have another set of solution, which is 1 by root 2, 2 plus 1. Is it clear? Okay. Okay. Now we come to another type of questions. F of x plus y is equal to f of x into f of y. Find f of x if f of 1 is equal to 2. How will you do this? I have to find f of x where f of 1 is given. So how will I proceed with this?
Still give us some time.
Yeah, sure. Think of it. This question you can mark it as important because you can get different forms of this question, and I'll tell you what kind of forms you can expect. I'll give you a hint. Now, when you're looking at this kind of a equation, okay, what is the connect that you have to think of? What is the connect between your right hand side and your left hand side?
So power.
Power is on your right. Left? Left, there is no power. Yes, you are on the right track. Correct. Go ahead.
Sir, I've got the answer.
Yes, tell me what is the answer.
Sir, if x equal to x to the power n.
X to the power?
Sorry, sir, 2 to the power x.
2 to the power x, correct. So tell me how you got it. Right.
So, firstly, I put x equal to y equal to 0. From that, I got f of 0 equal to 1. And then I tried for f of 2. So f of 2 equal to f of 1 into f of 1, which becomes 2 into 2 equal to 4. And then f of 3, which becomes f of 2 into f of 1, like 8. And continuing in this manner, we will get that f of x equal to 2 to the power x.
Okay. There is another way. You're right. Same thing. What I'm going to show you is the same thing, but here f of 1 is given. So this is the hint that is already given. So that means I will first put x equal to 1, y equal to 1. Right? If I do that, then f of 2 becomes f of 1 whole square. Correct?
Yes, sir.
So what would be f of 3 now? F of 3 will be f of 2 into f of 1. 2 is 1 plus 3 is 1 plus 2. And f of 2 is f of 1 square. So this is f of 1 whole cube. Similarly, f of 4 becomes f of 2 into f of 2, which is f of 1 to the power 4. And if you continue like this, then f of n becomes f of 1 to the power n, which means f of x will be f of 1 to the power x. Which is 2 to the power x. Absolutely right. Okay. Now there is a little variant of this question, f of x plus y equals f of x plus f of y. Find f of x if f of 0 is equal to 2. Are you able to solve this now with the given condition? Are you able to solve it with the given condition?
Sir, do we need to use this f of 0 equal to 2?
That is my question. I gave it intentionally. Are you able to solve this using the
No,
given condition?
no,
No.
sir.
So ignore this. So, see, the reason I gave it is because sometimes, in the question, there might be a condition which is given incorrect. I mean, maybe due to a printing mistake also. This might not be intentional, right? So if there is a situation like that, then ignore the condition and then try, and then see what you're getting. Ignore that condition.
Sir, I've got the answer.
Yes, tell me.
Sir, so firstly, we will start like uh, f of we will put x equal to y equal to 1.
Hmm?
Then we will get that f of 2 equal to f of 1 plus f of 1.
Hmm?
Yeah. F of 3, we will get f of 1 plus f of 2, that is 3f1. And in
Right.
this way, we will get that f of n equal to nf1.
Okay.
Therefore, f of x,
NF1, fine.
yeah. Therefore, f of x equal to x into f1.
Okay, correct. And is there a way to find F1? In this case, is there
Sir,
any way to, is there any way out to find F1?
no, sir.
No. You either need one of the values. You need either F0 or F1 or F2,
Yes, sir.
right? So now that if this value is given in place of this, if F1 is given as 4, then you know what the answer is. Clear?
Yes, sir.
Okay. Next. F of x plus y is equal to fx into fy, and sum of, okay, get the- let me take one question from here. 2 to the power k fk. Sum of fk, where k goes from 1 to n, will be what? It's an easy one. Use the solution that we got for fx. So you can use the solution that fx is equal to f1 to the power x. If you have this, you can directly use this.
Sir, then we need to use the simple GP formula.
Yes, absolutely. Simple GP. This is simple GP actually. You can see the power is in terms of x. So if you write it in terms of k, so basically this is f of 1 plus f of 2 up to f of n. This is what they have asked, right? So this is f of, everything will be in terms of f of 1, right? So f of 2 would be f of 1 square, and then up to f of 1 to the power n. This is simple GP, right? Clear? Okay. Now, okay. Next type. So domain and range I have covered. Okay. Now we'll do some special functions. So the first, have I covered gint function with you? Gint stands for greatest integer function. Have I done this with you? So let's say y is gint. This is called gint function, where box means greatest integer less than or equal to x. Okay. Now, what will be the nature of this function? Can you tell me? Try to draw the graph of this function and tell me what the graph will look like. How will the graph of this function look like? So let us write down the values x versus y. Let's start from 0. When x is 0, y is 0. When x is lying between 0 and 1, right? X is greater than 0 and less than 1. What would be the value of y? What would be the value of y? That means x is a positive fraction, which is less than 1, lying between 0 and 1. What would be the value of y? Y will be 0
0.
because y is the greatest integer less than or equal to x. Now, x, when x is a fraction, then you have to consider the integer value, which is immediately less than that. So, the integer which is less than, let's say 0.7 is 0. So, that means y is 0 when x is between 0 and 1, 0 included. Next, similarly, if you do x equal to 1, y becomes 1, and when it is lying between 1 and 2, then also it will be 1, right? And it will go on like this. So the values of the graph of the function will look like this. So the graph of the function, it starts from 0 and goes up to 1, but it is not touching 1. There will be a gap here. The moment it reaches 1, it jumps to the next value, which is 1. Again, it stays for 1 when it is almost near to 2. The moment it reaches 2, it will jump to the value of 2, and so on. So this is the graph of this function. On the negative side also, it will be like this. Clear? Understood? Yes?
Yes, sir.
So that means these would be the points of what? Discontinuity.
Discontinuity.
Okay? So that means this function is discontinuous for integer values of x. So that means if I tell you find the points of discontinuity of gint x when x is lying between -5 to +5, how many points of discontinuity you can see? X is greater than -5, less than +5. How many points of discontinuity? How many points of discontinuity? Check how many integer values you have between these two range. -1, -2, -3, -4, 1, 2, 3, 4, and 0. So 9. So there are 9 integer values between these two values of x, right? So the number of points of discontinuity of this function between the points -5 to +5 is 9, right? Clear? Everyone got it? Now, if I do give you this x square minus 4 and x is lying between -3 to +3, find the number of points of discontinuity. Try this. How many?
Sir, 3,
What are the 3?
0, -3, and -4.
No, no. Anything which is inside this will be discontinuous at integer values of this. Now, let me take this whole thing as something. Let's say I take this as p. So basically, I am trying to find the points of discontinuity of y equal to gint of p. And x is lying between -3 and +3. What should be the range of p? What should be p? You put -3 in place of x, you get 9 minus 4, 5. You put +3, you get again 5. And x square minus 4, this is a quadratic, right? Correct? So when x is 0, then this is -4. You have to be very careful when you are doing this kind of questions, right? See, the values, if you consider the values of x and p. Now, x is lying between -3 and +3. So when this is -3, p is x square minus 4. So this is 5, right? Correct? Now, when this is +3, this is again 5, right? Now I have to look at x square minus 4. Now x is lying between -3 and +3 means uh, this variable p will be minimum when x square is minimum. X square minimum is 0. So that means when x is 0, this is -4. Understood? Is it clear?
Yes, sir.
So P can vary from -4 to +5. This is the range of P. Correct? And one more thing, it would be greater than less than 5, because x is greater than -3 and less than +3. So it will not be equal to 5 ever. But x can be equal to 0, right? Because 0 is within -3 to +3. So if x is equal to 0, P can be equal to -4. So this side would be equal to. So P has to be greater than equal to -4 and less than 5. Right? Clear? So that means what will happen? The values of P will go from 5 to -4 when x goes from -3 to 0. And again, when it goes from 0 to +3, this goes from -4 to +5. Are you able to follow this?
Yes, sir.
Everyone? X is going from -3 to 0, and P is going from 5 to -4. And when x goes from 0 to 3, P goes from -4 to 5. And -4 is included, 5 is not included. So that means the numbers that you have to consider is 4 to -4 and then back to 4. So how many are there? 4 to -4. You keep -4 separate. So -3 to 4. How many numbers are there?
Sir, 8.
8. So 8 on this side, 8 on this side, and then you have -4. So there are 17 points of discontinuity. Clear? Understood, everyone? Yes?
Sir, can you please repeat once?
Sure. That's why I'm asking so many times. If you have even one small doubt, please ask. Okay? Because these concepts will be required in problems based on this, where the questions will be a little more difficult, but the concept will be the same. And I'll give you an example after that. So let's take it stepwise. So what is the range of x given? -3 to +3. And y is the gint function of x square minus 4. Now, what is the meaning of a gint function? A gint function means if I write y is gint of x, that means it is discontinuous for integer values of x. Simple as this. Just understand this. Discontinuous for integer value of x. Now, the common mistake that students make is when they see this function, they put integer values of x and they calculate from -3 to +3, which is not correct. Because it has to be discontinuous for integer values of x. And what is x here? X is whatever you see inside the bracket. So, therefore, I have to put something for x square minus 4 to make it in that form. Now it is in this form, gint of p. So this will be discontinuous for integer values of p. Is it clear up to here?
Yes, sir.
Right? This is the definition of gint function. If you draw the graph, you will see, as I showed in the previous case, that gint of x will be discontinuous for all integer values of x. So gent of p will be discontinuous for all integer values of p. Now the problem becomes simple. That is, I have to find how many integer values will p have for the range of x given. So for that, I just simply calculate the values of x given and the corresponding value of p. So the lowest value of x is -3 and it is greater than, not equal to. So it is -3. So if I put x equal to -3, p becomes +5. -3 whole square is 9, -4, 5. Similarly, if I put +3, then it becomes +5 again. Correct? So the maximum value that p can take is +5. Is that clear?
Yes, sir.
Now look at the function p. P is x square minus 4. Now for any value of x, x square is always greater than equal to 0. So the minimum value of x square is 0. Therefore, the minimum value of p has to be 0 minus 4, which is -4. And that will happen when x is equal to 0. Clear? Understood?
So, sir, repeat this portion once.
P is defined as x square minus 4. Right? And I'm trying to find the minimum value of p. What is the minimum value of p? P will be minimum when x square is minimum. X square is a square function. A square function can never be negative. The minimum value can be 0. That's the definition of a real number. X square is always greater than equal to 0. So the minimum value of x square is 0. Clear?
Yes, sir.
So if the minimum value of x square is 0, then you put 0 here. So minimum value of p becomes -4. So that means when x is -3, then x is -3, p is +5, and then it becomes -3 to 0. It goes from +5 to -4, and then from 0 to +3, again it goes from -4 to +5. Clear? Now bear in mind that x is greater than -3 and less than +3. So it will never reach +5. It will be between +4 to -4, and then again back to 4. So this is the range that you need to consider. So -4 to -3 to 4, there are 8 numbers. -3, -2, -1, 0, 1, 2, 3, 4. 8 numbers. So between -3 to 4, 4 included, there are 8 numbers here. And on this side also there are 8. And then you have -4 in between, which is 1. So 8 plus 8 plus 1, 17. Is it clear? Have you understood now? Okay. Okay. Y is equal to gent of sin x minus 2. Okay. And x lies between -4 to +4. Find the points of discontinuity. Or let me make it simpler since it's sin x. Let me give it as greater than -2 pi, less than 2 pi. So find the points of discontinuity. So once again, you have to take whatever is inside, take it as something p. So p is sine x minus 2. So now you are trying to find y equal to gent of p. So if x is greater than minus 2 pi and less than 2 pi, what should be the range of p? What happens to sine x when x is minus 2 pi?
Sir, it becomes 0 and hence p becomes minus 2.
Very good. So x is minus 2 pi, p is minus 2. Now when x is 2 pi, what is p?
Sir, same.
2. Minus 2, sorry. Now, therefore, p, one side of p will be minus 2. I don't know whether it is negative or positive. I mean, I don't know whether it is greater than or less than. Right? So, what will be the other value? How do I find the other one?
Sir, the minimum value of sin x function is -1.
Very good. Excellent. So now I have to focus on this one. Okay. So minimum function, minimum value is -1, -2, -3. So p minimum is -3. Okay. And what is the maximum then?
So 1.
-1.
-1. So what do you notice? What is the difference between this one and the previous one I gave? What is the difference? Again, this is a common mistake that happens. See, in this case, when I calculated for p, okay, then 5 came out as the upper limit of p, right? And I could get that by putting x equal to -3 or +3. That is because here p is a quadratic. So as x increases, or rather as x square increases, p will increase. So only thing is I need to find the minimum of x square. Rest of the values of x square will be always positive. And that positive value will be the maximum positive of x here. So it's very straightforward. But here, the common tendency is once you get the value of -2, most of the people, they assume either greater than -2 or less than -2, which is not correct. Understood the difference? That is why I said this particular gent function is a very important function from exam perspective, because, and I'm giving you simple examples, and there are actually there are more complex examples of this function which you will get in your exam. So in this case, if I assume -2 to be either one side of p, then I'm going wrong, because here the value of minimum maximum of p will depend on the minimum maximum of sin x. So here minimum of sin x is -1, maximum of sin x is +1. So if I put -1, then p becomes -3. If I put +1, p becomes -1. So therefore, p has to lie between -1 and -3. Now another interesting thing. Now sine function is sinusoidal, is periodic. So if you observe from -pi to +pi, -2 pi to +2 pi, the sine function behaves like this. Right? This is -2 pi, this is -pi, this is 0, this is pi, and this is 2 pi. Correct? Right? Right? Agreed?
Sir, yes, sir, but it doesn't reach 2 pi.
Okay, it doesn't reach 2 pi. I'll come to that. In this case, it's not reaching 2 pi, but the behavior of the sine function is this. That you agree?
Yes, sir.
Right? Now I am concerned with these two values. Where am I getting sine? Not this one. Sorry. Now I'm interested in these two values. These four values. Where is it happening? It is happening for x equal to minus 3 pi by 2. This is minus 3 pi by 2. And this is minus pi by 2. And then again pi by 2 and plus 3 pi by 2. So these are the points that I'm interested in. Right? So when it is minus 3 pi by 2, which is inside the range of minus 2 pi to plus 2 pi, all these four values are inside the range. That means both the maxima and the minima will happen 2 times each. Clear? So therefore, P will be greater than equal to minus 3 and less than equal to minus 1. Is this part clear?
Yes, sir.
If you do not draw the diagram separately, you will not be able to identify this behavior. So always try to draw a rough diagram to see uh, if your function is matching what the diagram is showing. So that means I need to have two set of values of minus 3 and two set of values of minus 1. So it will be minus 1 at this point and at this point, and it will be minus 3 at this point and at this point. Correct? Correct? Agreed? Okay. And here it is minus 2, and then here also it is minus 2. So now what is the picture? If I now look at the values of x versus p. So when x is obviously x is greater than minus 2 pi, so I will not consider minus 2 pi. I will consider the next value, right? Minus 2, minus 1. So there is nothing in between. So x is minus 3 pi by 2. P is minus 1. Then x is minus pi. P is, sign would be 0 here. So P would be minus 2. Then x is minus pi by 2. P would be minus 3. Then x is 0. Then P would be minus 2 again. Then x is plus pi by 2. P would be minus 1. Then x would be pi. This is minus 2 again. And x is 3 pi by 2. This is minus 3. So see, all the values are repeating twice. Right? So there will be 7 points of discontinuity here. Is it clear? Once again, the common mistake that people make is even after they get minus 3 and minus 1, they will check for minus 3 to minus 1. So there are three values both included. So the answer they will write is 3, which is not correct. Clear? Because here the graph is very important. -1 is getting repeated twice. -2, which is when x is 0. No, sorry, sin x is 0, is happening at this point, and this point. So 3 points where t becomes -2. So there are 3 points of -2 and 2 points of -1, 2 points of -3. So the answer is 7. Everyone clear on this?
Yes, sir.
There is a lot of mistake that happens. I've seen from my past experience, a lot of mistakes that happen in this kind of questions. Okay, to avoid those mistakes, please draw this diagram whenever you have a, especially whenever you have a trigonometric function. Because trigonometric functions, especially sine and cos, are periodic. So the same value will get repeated multiple times depending on the range of or the domain that you are looking at. So you have to be very, very careful when you're dealing with trigonometric functions. Okay? Okay. Now today we are almost up on time. I'll just introduce the next function and next day I'll show you combinations of that.
Sir,
Hmm.
sir, today we did a sum of finding the domain of root over x in minus root over 1 minus x squared.
Hmm.
Sir, can we find the range of this function?
This one?
Uh,
Yes, yes.
we did.
Which function you want? This one? Last one?
No, sir. No, sir. A bit above.
Oh, that
Why?
one which I did earlier.
Yes,
This
sir.
one.
Yes, this one. Yes, sir.
Ah, okay. Root over x minus root over 1 minus x square. This one, right?
Yes, sir.
Oh, sure. Y equals root over of x minus root over of 1 minus x square. Right? So, what is the domain that we got? We got, I think, minus what did I solve? 1 by minus 1 by root 2 to minus 1, right? And 1 by root 2 to plus 1, right? If I'm not wrong. That was this. Yeah. Minus 1 to minus 1 by root 2 and this one. Okay. Minus 1
Sir,
to minus, yes.
sir, will this include the domain -1? Because if it is -1, it becomes 1 minus 1, 0, and x becomes -1.
Ah, you're right. It will not include. So one side will be, thank you. You are correct. So did I include this? Oh, very good. Yes, when I'm combining these two, I have to be careful. If I put -1, then it becomes -1. Yes. So -1 here, x square greater than equal to this. So less than equal to minus 1. 0. No, I think there is a mistake here. 1 second. X square is greater than this. 1 minus x square, 2x square greater than equal to 1. X square is greater than equal to half. X is greater than equal to 1 by root 2 or less than equal to minus 1. I put This 1, this is 0, and this is minus 1. Not. This is 1. Yeah, actually, this one is incorrect here. If I put it back here, if I put it back in the original function, then any value which is less than minus 1 by root 2 will satisfy this one, but it is not going to satisfy this one. So it will actually, if I put minus 1, this becomes minus 1, which is not correct. So, okay, so this is incorrect. Thank you. So this side will not hold. So it should be only greater than equal to 1 by root 2 and this. So that means this is not going to come. Thank you so much. See, this is what you need to watch out for. Okay, I made a mistake here. Okay, everyone understood what he said?
Sir, why is the right side not working here?
Because when I took this, okay, x square greater than equal to a square means normally what do we write? X is greater than equal to a, or x is less than equal to minus a, right? That's what we
Yes,
do,
sir.
and that's what I had done. But if I put this value in this one, then this becomes 0, but this becomes negative. You put minus 1 by root 2 here,
Yes, sir.
right? Minus
Negative.
1 by root 2 whole square is minus half. 1 minus half is half. So this is root over of that. And then I have a minus 1 by root 2 again with a negative. So negative, negative becomes negative, and this is under root. So that is why I cannot have this.
Sir, it is because in the third step we have taken squaring on both sides. That's why.
Correct. Which anyway I have to do to solve.
Yes, sir.
But
But in the previous step, it was already technically proved that x should be greater than 0 because x is greater than or equals to under root 1 minus x square.
correct. Right.
Yes, sir.
So
So
this is
the domain is
yes. So that is why you have to be careful here. So this is the only solution. Therefore, this is the only solution. 1 by root 2 2 plus 1.
1.
So now you just put that and find the range. So 1 by root 2 2 plus 1. So therefore, you put 1 by root 2. So what do you get? 1 minus half. So 1 by root 2, right? So 1 by root 2 minus 1 by root 2 will be 0. So when x is 1 by root 2, y will be 0. Or let me write it like this. When x is 1 by root 2, y is 0. Right?
Yes, sir.
When x is 1, this is 1. Right?
Yes, sir.
So that is your range, 0 to 1.
So don't we need to check if there are any value greater than or less than in between, excluding the extreme points?
Excluding the extreme points. Okay. You can actually do one thing. You can do you can do it like this. So you can do a dy dx equals 1 by 2 root over of x minus root over of 1 minus x square into derivative of this one, which is 1 minus derivative of this. So 1 by 2 root over of 1 minus x square into minus 2x So this becomes 1 by 2 root over of x minus root over 1 minus x square into root over 1 minus x square minus x minus of minus x, so plus x by root over of 1 minus x square. So this dy dx will be 0. If it has to be a max, if there is a point of maxima or minima, then this dy dx has to be 0. So that means 1 plus root over of 1 plus x square plus x is 0. That means root over of 1 plus x square is minus x. So 1 plus x square is equal to x square. So 1 is equal to 0, which is not valid. So this cannot be 0. So there is no point of maxima or minima in between.
Yes, sir.
That proves it.
Yes. Sir.
Okay, so that's all for today. We continue in the next class. Okay, thank you. Bye.
Thank you, sir.